Imagine you are given a expression 2 raised to the power 3 equals to 8, right? Now we all know that what this expression means. This simply means 2 multiplied by itself for 3 times, right? 2 multiplied by itself for exponent times. This is what this equation means, right? And now if we calculate this multiplication, we get 8 out of it, right? Now, if you are asked to find out 2 raised to the power x is equals to 1024, to find the value of this x, how can you do that? I mean, is there a way of defining or getting this value of x, an easy way of doing it, right? And yes, there is a tool in mathematics which we call logarithms, right? And now if I use that logarithm here, I will write log of 1024 at base 2 equals to x. And now I can easily calculate this thing using a hit and trial method. Maybe I can write 2 to the power log base to 1024 equals to 1024, right? And I have to find the value of this one, right? And this is equals to x, so 2 to the power of x equals to 1024. And if I'm not wrong, 2 to the power 10 is equals to 1024, so the value of x must be equals to 10. And that is how we calculate logarithm, and that is a basic idea of logarithms, right? So now let's do some examples of logarithms. Let's say we have a base b raised to the power x equals to a. How will you write this in the forms of logarithms? We can just write down log base b of a equals to x. This equation has the same elements, all the same variables as this expression has the all the variables used in this equation, right? There is a, there is x, and there is a b, right? I mean, you have to understand logarithms just like exponent. I mean, those are the exponents, right? See, what is this x in this equation? This is exponent, right? And this base and this logarithm is also exponent. I mean, this is equals to x, right? So this x is nothing but equals to this log of a at base b, right? And that is the basic idea of logarithm. Now let's do some examples. Let's say we have log base to 8. So what this should be equals to? I mean, to what power 2 must be raised to get 8 out of it? It should be equals to 3, right? Now let's do log base 3, then 81. What is this going to be equals to? This is basically asking you to what power 3 must be raised to get 81 out of it. So this should be equals to 4, right? Similarly, log base 4, 16, this should be equals to 2, and log base 100, then 1. What is this going to be? I mean, to which power 100 must be raised to get 1 out of it? Let's to calculate this, let's write this in the form of exponential equation. We can write that 100 raised to the power x, let's say this is equals to x, and this is equals to 1, right? So to what power this 100 must be raised to get 1 out of it? As I know, the value of x should be 0, because if we raise any number to 0, we get 1 out of it, right? So the value of this should be equals to 0, or maybe you should note that down, log of any number and is equals to 1, then it is always be 0, right? Now let's talk about some more examples. Log base b of b should be equals to, let's say it is equals to x. So to what power b must be raised to get b out of it? I mean, we have the same number as this, right? And I can say that this b is raised to the power 1 right now. So x must be equals to 1 unless b is not equals to 1. I mean, there is a condition for this property of exponents to be applied, which is b should be greater than 1, or this exponent won't be equals or maybe equal. I mean, that doesn't matter if they are equal or not, but if the base is equals to 1, then this equality between exponent won't matter actually. And I have already a video on my channel for this. But this is a condition for the property to be applied here. We need b greater than 1, and then we can have the exponent equal in this both expressions. We can have x equals to 1, right? And then we can say that if the base is equals to the number in logarithm, we have 1, right? Whenever you see same numbers in the base and then in the in front of the logarithm, I don't know what we call this one, this number, we are always going to get 1 out of it, right? Now let's talk about some more logarithms. For example, log 2 of 1 over 2. What is this going to be? I mean, we have to get 1 over 2 out of this 2. If we raise some this 2 to some number, we have to get 1 over 2 out of it, right? So we can write that 2 raised to the power x equals to 1 over 2, right? So we can write this thing equals to minus 1, right? If you raise anything to the power -1, you are going to get the reciprocal of it, right? I mean, x raised to the power -1 is equals to 1 over x, right? Now let's do another example. Log root 3 of 27. How will you solve this one? In the same way as we did this one, right? We can write root 3 to the power x, if this is equals to x equals to 27, right? Now I guess we will use this property right here to solve this one, and I will write the basis same in both of these terms. So this should be equals to 3 to the power 1 over 2. So x equals to 3 to the power 3, right? Now if you may remember, anything raised to the power m and then whole raised to the power n is equals to a to the power mn, right? I will use the same property right here, and this should be equals to 3 raised to the power x over 2 equals to 3 to the power 3. And now bases are the same and those bases are greater than 1. We can apply this property here, which is exponents are going to be the same if the bases are equal and greater than 1. So I can write that x over 2 equals to 3 and x equals to 6. If we raise root 3 to the power 6, we are going to get 27 out of it, and this logarithm, the value of this log is equals to 6, right?